All right, here we go. This is your introduction to series circuits. How we define series circuits is we look at how many paths there are for current to flow in a circuit. And as we can see here, we have really just one path for current to flow. And since we have our polarity set up, we have a positive here and a negative here. We're going to talk about flow, electron current flow versus conventional current flow. And conventional current flow says, that current flows from positive to negative, and electron current flow says that current flows from negative to positive. But it really doesn't make any difference at this point because all the calculations are all the same. So what we need to talk about first, if you look at the top right hand corner of your screen, you're going to see two triangles. These are the Ohm's law triangles, and I'll write that down. Ohm's law. Now, the Ohm's law triangle tell us about the algebraic relationship between voltage, amperage, and resistance. Now, voltage we see here as an E. That's the letter that we use to denote voltage. I we use for amperage, and R is for resistance. The other triangle below it is a power, voltage, and amperage triangle. So power is equal to voltage times amperage. Very easy to do these calculations. Basically, you just cover up whatever it is you're solving for. So for instance, on the top triangle, if I'm solving for E, voltage, I can just take my amperage and multiply my resistance. If I want my resistance, I can just cover that up, and then I'm left with my voltage over my amperage. Same thing for power. If I want power, I have my voltage times resistance. Say I have my power and amperage, but I don't have my voltage, I can simply take my power and divide by my amperage. So that's the algebraic relationship that we're going to use here. Now, this very simple series circuit here that we have, we can tell that it's a series circuit because it only has one path for current to flow. Kirchhoff's law states that the amount of voltage around a loop must equal the voltage applied. And since we only have one resistor here, then that resistor voltage must equal our applied voltage. And we'll get to that in a second. I just wanted to introduce you to Kirchhoff's law. So the first thing we want to do is determine what our totals are. So we have a total of 50 volts. We don't know our amperage total. We don't know our power in watts total. And we don't know our resistance in ohms total yet, or do we? We can look over here at our resistor 1. Since there's only one resistor, there's only one value of resistance in this circuit, then our total resistance must equal that value. So my total resistance in this circuit is going to equal 10 ohms. And we use the ohm symbol in order to denote resistance. So now I have two values for my totals here. I have 50 volts and 10 ohms. So if I was to determine what my amperage is, I can come over here, top right hand corner, and I can take a look at some values over here. So let's take a look. So I want to know my amperage here. So my amperage would be a function of my voltage divided by my resistance. So let's do that over here. So I have 50 volts divided by a resistance of 10 ohms is going to give me 5 amps. Okay, so that's pretty simple. Now let's take a look at our power. So what values do I have? I have voltage, amperage, and resistance. And in my Ohm's law triangle over here, I can find my power by multiplying my voltage here times my amperage. So let's give that a try. So my voltage of 50 volts times my amperage of 5 amps will give me 250 watts. 250 watts. So I only have one resistor in this circuit, so it's pretty easy to make an assumption that, well, all of the power dissipated in the circuit is going to be from this one resistor, which is 250 watts. Now I want to know what my voltage is, and like I said earlier, Kirchhoff's law states that the voltage around a series circuit must equal the voltage applied. Since we only have one resistor, my voltage at that one resistor must equal my applied voltage, which is 50 volts. And because I only have one path for current to flow in this circuit, my total amperage must equal my amperage going through this resistance. All that current must go through that resistor. Must go through that resistor. So the total amperage of 5 amps must equal the 5 amps for resistor 1. And you can check that algebraically. You can say, well, my amperage here, my amperage over here is equal to my voltage divided by my resistance. So my voltage divided by my resistance, 50 divided by 10, must equal 5. So it works out. In the next video, what we're going to do is I'm going to erase some of these values here. And let's add another resistor. So let's erase the 50 volts. Let's erase all these values here and add an additional resistor in series to this circuit. So we'll get rid of this as well. We'll keep the voltage of 50 volts here applied. So that's not going to change. And we'll even erase this here. So let's take a look. And I'll put another resistor in right here, we'll say. Let's change my pen color to black and draw that resistor. All right. So this we're going to call resistor number 2. And what we'll do is we'll change the resistive value. I want to use the same numbers as before for totals. So what I'm going to do is I'm going to change resistor 1 to, let's change that to 5 ohms. And we'll say resistor 2 is 5 ohms. All right, so in this series circuit we have two resistors that are in series with each other, meaning that there's really only one path for current to flow. All the current must go through this resistor, and then it must go through that resistor, and it must go home. So my total resistance in the circuit is going to be the sum of the individual resistors in the circuit, which means just in a series circuit, you just add up the resistors. It's really just as simple as that. So my total resistance in the circuit is going to be equal to R1 plus R2. So R total equals R1 plus R2. And I have 5 ohms of resistance there plus 5 ohms of resistance there. So I must have a total resistance of 10 ohms. So really nothing's changed except for the fact that I've reduced the amount of resistance in half and put them in series with each other. So nothing's changed so far, but there will be some changes in terms of power and voltage. So let's take a look at that. Let's find out what our total amperage is. That hasn't changed at all because my total amperage is a function. If we look over here, top right hand corner, my total amperage here is a function of my voltage times my resistance. Well, it's my total amperage is equal to my total voltage divided by my total resistance. So if we look at my total voltage of 50 volts, my total amperage will be 50 volts divided by 10, which is 5 amps. So same thing as last time. No difference there. And the amperage stays the same throughout the circuit because it must run through that resistor and it must run through this one. So my amperage at resistor 2 is going to be 5 amps, and my amperage at resistor 1 is going to be 5 amps. Now here's where it changes a little bit. So now we want to determine what our voltage is here, and I'm just going to move back to green. My voltage at this particular resistor will start at R1 over here. My voltage at R1 must be equal to my amperage of 5 amps times my resistance of 5 ohms. So 5 times 5 equals 25 volts. And I have the same values over here. So I'm just going to write E2, E meaning voltage. So my E2 is equal to my I2 times my R2. So 5 times 5 is 25. Now Kirchhoff's voltage law says that the sum of the voltage drops in a series circuit must equal the voltage applied. So we're saying that the sum of the voltage drops in the series circuit, so voltage drop at 1 plus the voltage drop at 2 must equal my total voltage in the circuit. So my total voltage in the circuit is 50 volts, and I have 25 volts at E2 and 25 volts at E1. So I have 50 here and I have 50 here. So Kirchhoff's law has been satisfied. It's true. So now let's take a look at our power in the circuit here. So my power is measured in watts, and my power, if we look at the power Ohm's law power triangle over here, my power is equal to my voltage times my amperage. So let's do this one over here. My power is equal to my voltage of 25 volts times my amperage of 5 amps. So 5 times 25 is 125 watts. And over here, my power at resistor 2 is the same thing. That is my voltage times my amperage. So 125 watts. Now your power total is very much similar to my voltage total in that the sum of the power dissipations around a series circuit must equal my total power in the circuit. So my total power must equal my power at 1 plus my power at 2. And my power at 1 is 125 watts, and my power at 2 is 125 watts. So it gives me 250 watts, which equals my total power. And you can check that by using Ohm's law, and we can say, well, P total, power total, equals my voltage total of 50 volts times my amperage total of 5 amps. So 50 times 5 is 250 watts. That's your first instruction on series circuits. Hopefully that's cleared up any of your concerns about series circuits, and I have many more videos. Thank you for watching.